5 minutes now.
Yeah, it does it.
Good? Warn me when it's close. Anyway, I know what you missed, but here's a star, here's a planet going around it. They each pull on each other from gravity. And the small mass planet does a big orbit, but the big mass star actually moves a bit too. It actually accelerates as well. So, if you're far away, you cannot see the planets, but you can see the star. And so from far away, do you actually see the star moving as a circle? No. What you do see, though, not your eye. Your eyeball cannot tell this. But if you trace a telescope on it and leave it there for a month or 2 months, what the telescope might notice is that the star does a little bit of a wobble, side to side. And so when it sees that, and it appears to be periodic, or it repeats, then people say, oh, wait a minute now, there must be something causing the star to wobble. And so you can imagine, put yourself down here. This is the way it has to be oriented. You're not looking down on it like this, because you're not seeing this anyway. You're here, and you're looking at the star this way. What do you notice? You can tell you're not seeing the motion. What a computer can pick up is red shift, blue shift. Where, in this motion, would you actually notice blue shift? Call it out. Call out blue shift when you would notice it.
The right side?
That's it. Ready? Now. Blue shift.
Wait, why?
Right at this point, the star is actually moving toward us. Right now, it's moving toward us. Now it's not. But during that small period of time when it's moving toward us, its spectrum, mostly hydrogen, actually appears a little bluer. That's like page 4 of the homework. The lines move over a little. It appears a little bluer than it normally does. And now it appears redshifted. Blue, red. Blue, red. And if you see that repeat back and forth, and you could put it on a computer model and figure out the mass of the planet going around it, guess what? Come up with a fancy name. You just discovered a planet. This is how most of the extrasolar planets were discovered at first. They have other methods now too, but this is one of the most reliable and the first methods that really got going. So, this sort of explanation, that's how it really works. You look at the frequency, and then you infer the motion. So let's do that here real quick. All of these, it's talking about the frequency. So, if the frequency is greater than you expect, what does that mean about the motion of, here it's about galaxies. What is the galaxy doing if the frequency appears higher?
Moving towards
blue shift. Yeah, it's a blue shift and it's approaching. You can say it's approaching Earth. How about here? Steadily increasing.
Approaching Earth or constant.
Well, be careful. Yeah, if it's steadily increasing, it's accelerating toward. If it's as expected, it's not that it's not moving at all. It's that compared to us, no relative motion. So we could both be moving, we're just moving the same way.
If you said stationary, would you get that wrong?
Again, you probably would do this as a multiple choice. Just, do you realize the difference?
Yeah.
Stationary, you're getting the right idea, but both of us could actually be moving, as long as you're the same. So don't be fooled. Like if you're on the fire truck, if you're driving with the truck, you're not going to notice any difference. So it doesn't have to be sitting in the parking lot. Steadily decreasing, of course, would be...
Accelerating away.
Yeah, that's accelerating away. And again, acceleration is less likely to show up. And of course, if it's less than expected, it is receding or moving away from Earth. How much time we got left on that? Would you check, please?
10 seconds.
Left?
Oh, maybe it's just 30. I can't remember.
Yeah, about 30.
Okay, so let's talk real quick.
Take a break.
In Earth science, do you remember one of the pieces of evidence for the Big Bang?
No.
Oh, everything.
It was called
Pangea.
the redshift. Do you remember the redshift? The Doppler redshift? Not Pangea. Way before Pangea. Anyway, when you look at the galaxies around Earth with a telescope, a large percentage of them, the majority of them, are red shifted. The majority of them are red shifted, meaning they all appear to be receding from us. If they are receding from us, run that backwards, that means some time ago they were closer to us. Then that starts to fit together with the whole the universe is expanding model. By the way, not all of the galaxies are receding from us. Probably around 70% or so. Mr. Johnson, let's see what he says. They're trying to be here at 2, maybe 2:05. Okay, good. That's for you guys right there. All right, so pause that, would you?